So today we're going to do graphing from a table. So you're going to sort of notice we're going to start to shift. We've been talking about functions. We are still dealing with functions. Okay, we're just going to shift from some properties of functions to talking about how we can graph functions. So that's sort of our next big chunk that we're going to look at. Today we're going to start with graphing from a table. Okay, and realistically speaking, you actually know how to do everything we're going to look at today. I'm not going to show you anything new. I'm just going to put a bunch of pieces together that we already know how to do. So, for example, we already talked about before spring break, the week before spring break, we said if we had a function rule, this was the function rule we looked in our notes the week before break. If we had something like y equals 3x plus 4, right, we said if we had a table, if we had input values, x values, if we had a domain, okay, we could take those values and we could plug them in to find their corresponding y values. So if I have a table, and I say, okay, let's evaluate this function rule for -5, 2, and 7. We said that we could take those values, we could plug them in for x, and we could find their corresponding y values. Right? And we did that by doing 3 different problems, right? 3 different plugging and juggings. So I take that -5 and I would plug it in for x. So instead of saying 3 times x plus 4, I would say 3 times -5 plus 4. Okay, what is 3 times -5? And -15 plus 4? Right, and a lot of us were just picking up our calculator, right, and plugging that in 3 different times, which is totally fine. Okay, and then we'd repeat the process, except this time we would plug in 2. So now instead of saying 3 times x plus 4, we would say 3 times 2 plus 4. 3 times 2 is 6. 6 plus 4 is 10. And then we'd start over all again, and then we'd do the exact same thing with 7. So we'd say 3 times 7 is 21. 21 plus 4 is 25. Right? Remember doing that before you slept for a week? Today we're going to take that same idea. We're just going to be much more intentional with the values that we're finding. So now we're going to take something that's a function rule like this. Right, and we said that we could represent functions in multiple ways. As a table, as a graph, ordered pairs, mappings. Okay, so now we're going to look at how can I represent this function rule on a graph. The nice thing about a graph is that a graph has an infinite amount of points on it, right? A line is so many points that are so close together that they look like a line. They make a line. Or a curve, or whatever shape. Okay. So we're really going to have a way to write down all of the infinite numbers that we can plug into this without having to actually write them down. Right? We said if I sent Diego home and I said, Diego, plug in every single value into this and give me an output, right? Diego would never be able to finish that assignment. But he could represent that assignment in a graph. Okay, so here's how we're going to do that. We are going to start by making a table. And we are going to try to pick some points that we can then graph on a coordinate plane. So when we're picking these points, we want a couple things to happen. We don't want fractions. Why do we not want fractions? Well, fractions are hard to plot without having to approximate. If I want to plot 2/3, 7, I have to kind of guesstimate 2/3 in between 0 and 1. Or I need to make a very more detailed coordinate plane. Okay, so we're going to try to avoid fractions. Now, here's the deal. I'm saying at least 3 points for today. That does not mean that we always need 3 points. There's going to be a lot of times that we can pick 2. But right now we're still in this huge bucket category that we don't know exactly what our graph is going to look like. So sometimes you're going to have to make 7 points to kind of figure out what's going on. Sometimes you might only need 2. But right now I don't want you to limit yourself with 2, or you might think that something is happening that's not really happening. Okay, as you learn more and we sort of get more information, we'll be a little bit better at narrowing down how many points we need. Okay, our last rule is that they're going to have to fit on the graph. Why do they need to fit on the graph? Well, Alex is not going to let you plot off the graph. So it needs to fit in the space that it gives you. So we need to make sure we're picking points that will work for the graph space that we're provided. So no drawing 14 extra lines if you're doing it with paper and pencil and making it somewhere way up above it. Okay, it has to fit on the graph provided. So let's say for right now, we have a 10 by 10 graph to plot on. Would it be a good idea for me to choose an input value of 17? No, what's wrong if I pick 17? It's going to go off the graph, right? This is a 10 by 10 graph. I can't pick a number of 17. It won't fit. Okay, so I need to pick some numbers that are going to fit. What happens if I choose 10? I mean, 10 fits on the graph, but should I pick 10? Why not? What is 10 times 2? 20 minus 1 is 19. Is 19 going to fit on the graph? No, right? So I need to think about not only the value I'm picking, but also what its output value is going to be. And sometimes you'll pick a number and it won't work, and you have to cross it off and try a new one. Okay, but I always tell my students to think reasonably. What would be a really good number to probably pick? 1 is a good number, but I think there's one even better. 0. 0 is a really great number to pick. You're right smack dab in the middle of that graph, and who doesn't want to work with 0? It's nice and easy. Okay, so now the number isn't being provided to us, but we're having to pick a number. Okay, and so now I'm going to plug in 0 just like I was doing for my last one. And I'll say 2 times 0 minus 1. What is 2 times 0 minus 1? Negative 1. Right? And if you need to pick up your calculator and type in 2 times 0 minus 1, that's fine. Get a correct output value. Okay, what would probably be the next good number to pick? A 1. Okay, so we'll do the same thing. 2 times 1 minus 1. Do what?
It's 1.
2 times 1 minus 1 is 1. Yep. 2 times 1 minus 1 is 1. 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 2 times 1 minus 1 it realistically does not matter what number you pick next. So whether you decide to pick 2, whether you decide to pick -1, whether you decide to pick 5, I don't care. It just has to fit on the graph. Okay, so anybody have a preference as to what we want to pick next? 2? Okay. So 2 times 2 minus 1 is 3. Okay, so we're going to check and make sure we meet our qualifications here. Do we have any fractions? Nope. Do we have at least 3 points? Yep. And are they all going to fit on our 10 by 10 grid? Yep. So now we're going to go back to the info we learned about functions. We said if we were given a table, that this table was another way to represent ordered pairs. So we knew that right here on the table, this was telling me that this is actually an ordered pair of 0, -1. Okay, and this is actually an ordered pair of 1, 1. And this is actually an ordered pair of 2, 3. And so I am then going to plot those ordered pairs on the graph. So I'm going to plot the point 0, -1. Now, I've checked, I've looked. The majority of you are good with plotting points. You already completed it in ALEKS. You probably don't even know you worked on it. It was probably given in a knowledge check and you just got it correct to start with. Because plotting points is something we've been doing for a while. Right, not in here, but just in education in general. Okay, however, some of us are not, which means we need to make sure we're okay with this. Okay, so if we go to plot the ordered pair, 0, -1, this is the ordered pair x, y, where the horizontal is our x and the vertical is our y. So we are going to move on our x-axis first. Okay, this says to go to 0 on the x-axis. Right, 0 on the x-axis is in the middle. Then we'd have 1, 2, 3, 4, just like a number line. Okay, once we are here, we're not going to make a point. We're just going to sort of keep ourselves there, and we are then going to move to -1 on the y-axis. -1 is then down 1, right? +1, +2, -1, -2. So I'm then going to move to -1 on the y-axis. Right? I've taken care of my 0, I've taken care of my -1, so that's where I'm going to make my point. Okay, then I'm going to plot my next point. 1, 1. So I'm going to go to 1 on my x-axis, which is my horizontal, so I'm going to go to 1. Then I'm going to move to 1 on my y-axis, which is up 1, and so I will make a point here. Okay, then we will plot 2, 3. What does this look like? A line. Okay, so we're not going to connect the dots. You can't do this. That's not what's happening. Right? Diego was able to plug in points for forever. That's why he wasn't going to be able to complete that assignment. Okay, so this needs to be a line that continues all the way through. Okay, here's the good news, which it makes sense. We do more with deciding what shape something will make in second year algebra. So in the ALEKS program, if you plot 3 points and you click to make the graph, it will fill in what the graph is supposed to be for you. It'll either only have a line available, or you'll click something and it will fill in the graph that goes there. Okay, because at this point, we don't know about what every graph will look like exactly. For example, let's say we want to graph f of x equals x to the third power. My students will often say to me, Mrs. McKinney, we haven't done anything with exponents. Yeah, you're right, we haven't. We haven't done anything with what this graph looks like. Yeah, you're right, we haven't. But you absolutely can graph this. Okay, it doesn't require that you know anything. It requires that you make a table and you pick some good input and output values. Okay, so we're going to make a table. We need to stick to the rules that we had before. No fractions, fits on the graph, at least 3 points. And you'll see why I'm saying at least here. Suggestions of a good point we want to pick to plug in. Is 0. 0 is always our good starting point. Pick 0 first. I don't know why so many students don't. I think we've been a little bit programmed. Teachers tell us we have to pick specific things. Right? We have to use -1. We have to use 0. But you don't have to use anything. So let's start with 0. Okay, so we plug it in. We're going to get 0 to the third power. What is 0 to the third power? 0. Easy peasy. What do we want to plug in next? 1. Sounds good. What is 1 to the third power? 1. Right, you don't need to know that. You could put it in a calculator if you needed to. Suggestions on what number we would like to pick next? 2, sounds fine. 2 to the third power is 8. Okay, so we have at least 3 points. They all fit on the graph. Okay, none of them are fractions. So we're good to go. So let's plot here. So we're going to plot the ordered pair 0, 0. I'm going to plot the ordered pair 1, 1. I'm going to plot the ordered pair 2, 8. What does this look like? Not a line, right? So here's where we have to say at least 3 points, because do we have enough of a picture to know what this looks like going across the coordinate plane? No, right? It looks like we've got something going on right here with this sort of curve, but what's it going to do after that? Go up, go down, go flat, we don't know. So let's just keep looking. So let's try a point over here. What might we want to try as a point over here? -1, sure. Here you have to be careful. If you're going to use your calculator, which I would expect you to do, you have to make sure that's in parentheses, right? We've been talking about that. Calculator's a great resource as long as you use it appropriately. So -1 to the third power is not 1. -1. Okay, so if I plot -1, -1, little bit better picture, right? We at least now know we're kind of going down. What other point might we want to try? -2. What is -2 to the third power? -8. Now do we see what's happening here? I mean, your line might not be in there perfect, but you can get a general idea of what that is. The rule that I usually tell my students is don't make anything with a corner. Don't make anything a sharp turn. Right? We're not doing this. Okay? It's not like a connect the dots line to line. Try and make a smooth transition all the way through. I mean, because you're graphing, right? But again, that's the benefit of us using the ALEKS program. It's going to fill it in there nice and neat for you anyways. Okay, again, the idea is that we're just getting points that give us an idea. It doesn't have to be perfect, but points that give us enough information. Are we okay on that one? Okay, then one more example we're going to look at for notes. Y equals 2/3 x plus 2. So again, if we're asked to graph, we don't know any other way to graph it right now other than to just pick some numbers and plug them in and make a table. So what's going to be the first number we want to guess? 0. 0 is always the first number we want to try. So we'll say 2/3 times 0 plus 2. Okay, so 2/3 times 0 is 0. 0 plus 2 is 2. All right, you could type that in your calculator, get a number out, whatever. What number do we want to plug in next? Okay, so if we plug in 1, 2/3 times 1 plus 2, use your calculator, whatever, we'll get out 2 2/3. Does that meet our requirement? Nope. There's a fraction, so we can't use that. What could we plug in that would keep us from getting an output of a fraction? 3. Carson, why 3? It's the denominator. So when we have a fraction, okay, if there's a fraction, I mean, you can randomly pick until you get correct ones. That would be better than doing nothing, right? Try 0, try 1, try 2, try 3, try 4 until you get 3 that work. Okay, but if there is a fraction, you are going to pick 0. You are going to pick the denominator. Uh-oh. The denominator is the number at the bottom of the fraction. So we're going to pick this number here. Okay, so we'll do 2/3 times 3 plus 2, which will give us 4. And then we're going to pick a multiple of that. A multiple is a number that we can get when we count by it. So count then by 3s. 3, 6, 9, 12, 15. You can pick any of those. -3, -6, -9, as long as they fit. Okay, so what might we want to pick next? 6. Most of my students avoid negatives if they can. You could pick -3. Pick -6. So 2/3 times 6 plus 2. Again, you could use your calculator. 6. We have 3 points. They aren't fractions. They'll fit on the graph, which I'm giving you right now, which is 10 by 10. Most of the time, that's what ALEKS will give you. It'll give you a different measurement graph if it needs it for you to fit it. Okay, and so then we'll just plot those points. So we'll plot the points 0, 2. 3, 4. 6, 6. Okay, the reason why I say at least 3 points is 3 points is enough to decide if it's going to be a line or not. 2 points will always look like a line. Okay, so you need 3 points to decide yes, it is a line or no, it's not a line. Okay, but this looks like a line, so yes, it's a line. So there's our graph.